Video, we're going to go over circles quiz number 1. So in the first question, we need to write the equation of the circle that's given there. So to write the equation of a circle, first of all, the format should be x minus h squared plus y minus k squared is equal to r squared. And h and k are coordinates of the center of the circle, and r is the radius. Now, remember that they already give us the center. It is 0, 0. So I can just plug that in. X minus 0 squared plus y minus 0 squared. And now I just need my radius. So I just need to find the measure of this line segment over here. So I'm going to do that using the distance formula. So I'm going to do that up here. So x2 minus x1 squared plus y2 minus y1 squared. That is 9 plus 16. That is radical 25, which is 5. So the radius is 5. So that would be 5 squared. You can also write this as x squared plus y squared equals to 25, and that is equivalent. So either this over here or this over here, both of them are equivalent, and they would both be full credit in this question. For the next one, we can't clearly see what the coordinates of the center and the radius are just from looking at it. So we are going to have to complete the square. So to complete the square, we need to group our x and y terms together and move the constant to the other side of the equal sign. So I'm missing the second x term. So that's going to be a 0x because when you multiply 0 by anything, it goes away. So we can just use that as a placeholder. And I'm going to make a box because we're going to be completing the square. And then we have y squared minus 6y. And then our box. Moving the constant over, it's going to go from positive to negative. And I need to make my two boxes as well. There's going to be the purple box and the blue box on the side of the equal sign. I just ran out of space. Now remember, we find the number that completes the square by doing b over 2 squared. And 0 divided by 2 is just 0. 0 squared is 0. So that's the number that completes the square for the y terms. And remember, the easy trick for factoring when you're completing the square is that it's going to factor to whatever b over 2 is before you squared it. So 0 divided by 2 is just 0. I'm just going to put a minus 0. It doesn't matter. 0 doesn't have a sign, just to make it look like the equation of a circle that we want at the end because we know that it has minuses. So I'll just put a minus 0 instead of a plus 0. But it doesn't matter because 0 doesn't have a sign. Okay. Then negative 6 divided by 2, that is negative 3. So already I know that this is going to factor to negative 3 because our b over 2 is negative 3. And then if we square that, that would be 9. So all I have to do now is just add up what's on this side of the equal sign. I have negative 1 plus 0 plus 9, and that is going to be 8. So our center is going to be 0, 3 of our circle, and our radius is going to be radical 8. This is r squared in our equation of the circle. So r would be radical 8. We know that all of the arcs to total a full circle is 360 degrees. So if I do 360 minus 110, I get 250. And so let me write that here. 360 minus 110 equals to 250. And since these chords are congruent, I know that the arcs that they intercept have to be congruent as well. So 250 divided by 2 gives me 125 degrees for each of these arcs. In the next one, they give us the measurement of the central angle, and I know that central angles are equal in measure to their intersected arcs. And we're looking for the inscribed angle, and the inscribed angle is half the measure of its intercepted arc. So the inscribed angle would be 26 degrees. Moving on to the next one, we know that anytime we have a diameter and a chord that intersect, If the diameter is perpendicular to the chord, then it bisects the chord. That's one of our circle theorems. If a diameter and a chord are perpendicular, the chord gets bisected. And since we know that the radius is 5, all radii in a circle are equal. So if that's 2, this would need to be 3 to make radius OC 5 as well. So we have a right triangle here, and one side's 3 and one side's 5. And you can use the Pythagorean theorem to get the other side, but this is a Pythagorean triple. It is a 3, 4, 5 triangle. But if you didn't quite know that this was 4, just from looking at it and seeing a Pythagorean triple, we could use the Pythagorean theorem. 3 squared plus b squared is equal to 5 squared, because 5 is the hypotenuse of the right triangle. 9 plus b squared is 25. So that means b squared is equal to 16. So b is equal to 4. So that means the side of the triangle is 4. So this is 4 because these are equal. And so we have the length of BD is 8. 4 plus 4 is 8. Okay, here we have perpendicular chords. And if chords are perpendicular, the arcs in between them are congruent. And since we do have parallel lines, we do know that the alternate interior angles are congruent. And these are both inscribed angles. Inscribed angles are half of their intercepted arcs. So these are each 40 degrees. Okay, a ball rolling in a circular path that has a radius of 10 inches. So here's where the ball is rolling. And we need to find the distance the ball has rolled. So we're finding the length of this arc, the length of the arc that the ball has traveled. So the measure of the arc is 54 degrees. So that means the measure of the central angle here is 54 degrees as well. Central angles are equal in measure to their intercepted arcs. But we need to find the arc length. So that's what we're finding, arc length. So let me use my proportion here. So part over whole equals part over whole. Let's start with the arc lengths. The arc length of this sector, I don't know, so I'm going to call that x. The arc length of the entire circle is the circumference. That is 2 pi r. So 10 times 2 is 20, so that would be 20 pi. And then the central angle of the sector of the part is 54 degrees. And all the central angles in a circle total 360 degrees. From here, just cross multiply. 360x is equal to, let me type this into my calculator, 54 times 20, 1080 pi. And then just divide both sides by 360. Divide by 360. And I do want to put the pi button into my calculator. So this is 3 pi. But push the pi button into your calculator times pi, because the question does say to round to the nearest hundredth. That's 2 decimal places. So the arc length is approximately 9.43 inches, rounded to the nearest hundredth. Okay, the next one is in radians, and we're talking about arc length because it talks about the length of the intercepted arc. So it's an arc length question. And since we're in radians, I'm going to just use our formula for arc length. So that's arc length is equal to radius times central angle. The S stands for arc length, R stands for radius, and theta stands for the central angle. So we know the arc length. They actually tell us that the arc length is 18 centimeters. We know the radius, that's 9, and we're actually looking for the central angle. It says, what is the number of radians in a central angle? So we're solving for theta. So dividing both sides by 9, I have theta is equal to 2 radians. And that's the whole thing. You can set it up with a proportion, just like we set up the proportion over here. But instead of using 360 degrees, use 2 pi. But it could be a little bit difficult to cross multiply. So for arc length, if you're working with radians, I highly recommend the formula. And last, we are proving that AB is congruent to CD. There are many different ways to go about it, but the way that most people did and the way that I thought to do it was to first prove the triangle's congruent. And then after you prove the triangle's congruent, you can use CP/CTC to prove that AB and CD are also congruent. Now, people were doing this different ways, but the way I did it is I saw the vertical angles And then I realized that all radii in a circle are congruent. So I have the SAS here. People were also using about the inscribed angles that intercepted the same arc and using AAS, and that's fine too. So I'm going to write this up. It's pretty straightforward proof. So my first step is my givens. Please make sure that you write out the givens on a test or the Regents exam. I'm going to just mention all the radii. So CP is congruent to PB. DP is congruent to AP. And my reason is all radii of a circle are congruent. Angle CPD is congruent to angle APB. Intersecting lines form congruent vertical angles. And a lot of people were mentioning alternate interior angles. You don't have parallel lines here. So alternate interior angles are not congruent. You could have said angle D is congruent to angle B because they're inscribed angles that intercept the same arc AC. Or you could have said angle A was congruent to angle C because those are also inscribed angles that intercept the same arc DB. Another thing that people were doing is they were proving triangles congruent with AA. AA proves similar. AA does not prove triangles congruent. So if you want to use CPCTC, you have to prove the triangles congruent using a method for triangle congruence like SAS or AAS, which are two that would apply in this proof. Okay, triangle CPD is congruent to triangle BPA, SAS, and then from there, we can prove that AB is congruent to CD because we know the triangles themselves are congruent. So all the other corresponding sides and angles are also congruent due to CPCTC. And that's it.